What's up, Nick? What you working on? Just some hand tracking that allows you to do this. Whoa, that's awesome. Want to learn how to do it? Let's do it. What's happening, guys? My name's Nicholas Renat, and in this video, we're going to be going through hand pose estimation using MediaPipe. So you'll be able to use your webcam to be able to track and detect all the joints within your hand in real time. Let's take a deeper look as to what we'll be going through. So in this video, we're going to be going through a bunch of things, but specifically we're going to tackle three key problems. So installing MediaPipe. So MediaPipe is the library that allows us to perform hand pose tracking among a bunch of other solutions. What we're then going to do is detect our hand as well as our second hand, so we can actually do multiple hand tracking in real time using our webcam, and you'll actually be able to see those results rendered to the screen. And then what we'll do is we'll also save some images with our detection. So this means that you'll be able to take the outputs from MediaPipe and from your pose detection model and output them to a JPEG file or whatever file format you want using OpenCV. Enough on that, let's take a look as to how this is all going to work. So first up, what we're going to be doing is installing MediaPipe for Python. So specifically, we'll use a pip install for that, pretty straightforward. What we're then going to do is detect hands, and specifically our hands, in real time from our webcam feed. So for this, we're actually going to be using OpenCV to get a feed from our webcam. We'll then overlay our MediaPipe detection model, so you'll actually be able to see all those joints rendered in real time. And then we're actually going to output those images to OpenCV. Now this is part one. There's actually going to be a part two to this series where we'll actually do a little bit more sophisticated detections with our particular model. So we'll actually determine which hand is left and which hand is right. And maybe we'll do some additional stuff. But this is part one. We're going to keep it pretty simple. Ready to do it? Let's get to it. Alrighty guys, so in order to build our hand pose model, what we're going to need to do is three key things. As per usual, we're going to go through this step by step. So first up, what we're going to do is install and import our dependencies. So that's step number one. Then what we're going to do is draw our hand detection. So what we'll actually be able to see is as we put our hands up to the webcam, we'll actually be able to see all of the joints within our hand detected in real time. So this is the initial phase, or one of the first tutorials that I'm going to do on hand pose. The next one is going to be a little bit more advanced and give you some more capabilities for it. Then last but not least, to add a little bit of additional flavor, what we're going to do is output the images from our detection. So you'll actually be able to see the images with all of our hand pose models or landmarks actually drawn out to a JPEG file. So you'll be able to pick those up, work with them, play around with them if you want. First things first, what we're going to go on ahead and do is install our dependencies. So let's go and do it. Okay, so dependencies are pretty straightforward today. So what we've gone and written there is ! pip install MediaPipe and then OpenCV-Python. So MediaPipe and OpenCV are going to be our two core dependencies. So MediaPipe, if you've seen some of my previous tutorials around this, gives you a bunch of different computer vision solutions. So you're able to use it for hand pose tracking, holistic tracking, body pose tracking, facial landmark tracking, whole bunch of really, really cool stuff. Then OpenCV is an open computer vision library, which allows you to work with your webcam, allows you to work with images really, really well. So it's pretty much the standard when it comes to computer vision libraries. Now, the next thing that we're going to go on ahead and do is actually import those dependencies into our Jupyter Notebook. So let's go on ahead and do it. Okay, so those are our dependencies now imported into our notebook. So we've gone and written 5 lines of code there. So the first one is import MediaPipe as MP. So this is going to import all of our MediaPipe solutions. And if I actually show you MediaPipe, there's a whole bunch of different, that's the GitHub repo, MediaPipe. So there are a whole bunch of different solutions available inside of MediaPipe. So specifically, we're going to be working with the Python API, and we are going to be working with this hands model here. So you can see hands. So if we select hands, so you can see that you're able to get really, really sophisticated hand tracking. Now, the cool thing about this is that it's really, really quick. So it works on your computer, so you're able to see those detections in real time. So the advantage of it being quick is that it can be used in real time. So this is an example of the hand landmarks, and I've actually got this inside of the notebook, which I'll show you in a sec, actually. But basically, this is what we're going to be able to do. So we'll probably recolor it a little bit so it looks a little bit better, though. Okay, so that's MediaPipe. Then what we're going to do is import CV2, which is OpenCV. So import CV2. So that gives us OpenCV, and we're mainly going to be using OpenCV for our webcam feed. So we'll use OpenCV to connect to our webcam. Then we're importing NumPy as MP. So import NumPy as MP. So NumPy just makes it easy to work with your different outputs from your MediaPipe model. Then the next two are really all to do with output. So we're not going to use UUID and OS until we get to step number 3. But UUID allows you to generate a uniform unique identifier, or unique uniform identifier, one of those ways. So this basically allows you to generate a random string, which you're then able to use as your image, or we're going to use as our image name. So this means that we're not going to get any overlap when we actually capture our images. And then OS stands for operating system. So it is the OS library for Python. So it just makes it easy working with different operating systems. Cool. Alrighty. Now the next thing that we want to do is actually start setting up MediaPipe. So we're going to import, or we're going to set up our drawing utilities, and we're also going to set up the hands model. Because remember, we're going to be using this model here. And again, all the link to this code, including any references, are going to be in the description below, as are a couple of links to the previous tutorials that I've done. But again, if you've got any questions at all, by all means, do hit me up in the comments below and join the Discord server, because we're always pretty active on there. In this case, let's go on ahead and set this up. Okay, so those are our two MediaPipe components now done and dusted. So we've gone and brought in two additional things here. So first up, we've brought in our drawing utilities. So that's this line over here. And our drawing utilities just make it easier for us to render all the different landmarks in our hand. So when you actually get the output from the MediaPipe model, what you're going to get is a series of landmarks. So there's going to be one landmark for each individual joint in your hand. Now let me uncomment this so you can see it. Now, what I actually mean by landmarks is this. So each one of these dots, the red dots, represent a landmark. So, and a landmark is really a joint, really, in this particular case. So your wrist, your thumb, thumb CMC, thumb MCP. So I don't know what the MCP, CMC is, but basically each one of these is going to represent a landmark. So again, you can see that you get really, really sophisticated joint tracking for your particular model. So we're going to use drawing utils to help us draw all of those landmarks to the screen. Then we've actually brought in the hands model. So to do that, we've written MP, or actually let's take a look at how we brought in drawing utils. So MP underscore drawing equals mp.solutions.drawing underscore utils. Then we've brought in our hands model. So MP underscore hands equals mp.solutions.hands. And then we've brought that in successfully. So the hands model is actually this model over here. So everything that we need to work with this hands model is in this line over here. Cool. So that's all well and good. Now, the next thing that we actually want to do is actually start working with our webcam. So let's set up our feed, and then we'll start building on from that to be able to draw our detections from our MediaPipe model. So I'm just going to add in a new cell here and start writing this out. Okay, so that is our basic webcam feed. So again, I went through that pretty quick, but if you've watched any of my real-time videos before, this block of code will look really, really familiar to you. But what I'm going to do is I'm going to go through each step, we'll run it, and then we'll overlay our MediaPipe model on the top of it. So first up, what we're doing is we're getting our webcam feed. So to do that, we've written cap equals cv2.video capture, and then we've passed through that we want our video capture device number 0. Now, again, you might need to play around with this depending on what type of machine you're using and what device your webcam actually is. So on my Windows machine, it's device number 0, but on my Mac, it's device number 2. Again, sometimes you need to play around with this. If you get an error saying that the image is empty or your image must have 3 dimensions, then you might want to play around with that number. Then what we're doing is we're actually reading through each frame within our video capture or from our webcam. So to do that, what we're doing is we're saying while our capture is open, so while we're connected to our webcam, so while cap.isOpen, and then we've included a colon. What we're going to do is read each frame from our webcam. So to do that, we've written ret, frame equals cap.read. So the ret and frame variables are just extracting or unpacking the results from our cap.read function. So out of this, we're going to get our return value. We don't need that. What we're more interested in is this frame variable. So the frame variable is actually going to represent the image from our webcam. Cool, right? Then what we're going to do is render that image to the screen. So again, this is using OpenCV. So cv2.imshow. And then we've passed through what we want our frame to be named. So you'll see at the top in a second, once I actually run this, that the name of our frame says hand tracking. If you wanted to change this, by all means, go for it. But in this case, we're going to leave it as hand tracking. And then we've passed through a comma and then frame. So this represents our actual image. So to the cv2.imshow function, so this line here, you pass through two variables. So you pass through the name of the frame, or at least the two variables that we're going to pass through are the name of the frame, or the name of what you actually want your output to be, as well as the image that you want to show. And then everything down here is pretty standard in terms of gracefully closing down your window once you're done with it. So this is basically saying that if you hit Q on your keyboard or if you close down your window, you're going to break out of the loop and stop the feed. And once that runs, we effectively release our webcam using cap.release, and cv2.destroy all windows closes down our frame. So that is all well and good. Let's go on ahead and test this out. Just make sure we can actually get our feed from our webcam. So if we hit Shift Enter, looks like we've got a bit of an error there. Oh, this should be double equals. Let's try running that again. And ideally, you should get a little pop-up towards the bottom of your screen in your taskbar, and you can see that's all well and good. So my webcam's activated. I can see my feed on the screen, and you can see it's pretty quick. It's all rendering, all looking pretty good. Yeah, cool. Nothing crazy there at the moment, right? So we've got our webcam feed. Now what we actually want to do is overlay onto this. So what we're going to do is we're going to take the feed from our webcam, pass it to MediaPipe, make detections, render the results to the image, which you can see that at the moment is called frame. But before we pass it to the cv2.imshow function, we're actually going to apply our different detections to that particular image. So ideally, what you'll get back is not just a webcam feed, but a webcam feed with all of those real-time detections applied. So let's go on ahead and do this. So we'll take it step by step. So I'm not going to do it all in one big go. So we'll first set up MediaPipe to work with this feed, and we'll probably just print out our results. And then what we'll actually go and do is render. So let's go on ahead and do this. All right, so before we go any further, let's actually take a look at what we've got here. So I've gone and written 2 new lines so far, but before we go on, I wanted to sort of take a little bit of a break there. So first up, what we're doing is we're instantiating our MediaPipe Hands model. So we're basically going to be using this using the with statement. So with mp_hands.hands, and then we're passing through 2 keyword arguments. So these two here, let me zoom in on that. So we're passing through min_detection_confidence, and we're setting that to 80%. I'll come back to that in a second. And then min_tracking_confidence equal to 0.5, aka 50%. And then we're going to be working with this big variable as the variable hands. So whenever we reference hands, what we're doing is we're actually working with this. Now, these 2 metrics here, or these 2 keyword arguments, represent 2 specific things. So when you first use the MediaPipe Hands model, it's going to detect your hand, and then from that particular image, it's then going to track the hand. So what we're basically saying here is that initially we want our detection confidence to be 80% for that first detection, and then for the tracking, we want it to be 50%. So ideally, this sets how accurate our model is going to be. Now, you can set it to 100%, but then you might not always get the perfect detections, or it might not actually detect anything. If you set it too low, then you might sacrifice appropriate accuracy. So again, you want to play around. I found 80% for detection confidence and 50% for tracking confidence to be pretty good metrics. Then the next line that I've actually written here is this one over here. So what we're going to be doing first up is we're actually going to be recoloring the frame that we get from our webcam. So you can see that our frame is up here. what we're going to do is we're going to convert it from BGR to RGB. So when we get a feed from OpenCV, by default, the image color is going to be in the format BGR, so blue, green, red. But in order to work with MediaPipe, we need to send that image to the detection model as an RGB format. So basically, it's shifting around the color arrays. So we're initially going to convert it from BGR to RGB using this line here. So to do that, we've written image equals cv2.cvt color. So this function allows us to recolor an image. And then we're passing through our frame, which we got from up here. And then we're specifying what color combination we actually want to apply. So in this case, it's cv2.color BGR to RGB. So you can see that there. All right. Okay, now what we're eventually going to do, and specifically what we're going to do now, is we're going to set our image writable flag equal to false. So this just stops us from copying our image and ideally performance tunes. We're then going to make detections, set it back to writable equals true, and then we're going to recolor it back to BGR to be able to render our results. So let's go on ahead and do this. Okay, so we are now looking pretty good. So we went and wrote an additional, 5 lines of code there. So all of these lines. So let's actually break this up. So first up, what we did is we actually recolored our image. So we went BGR to RGB. Then what we did is we went and set our writable flag equal to false. So to do that, we've written image.flags.writable equals false. So again, set flag. Then what we actually went and did, so this line over here is probably the most important line out of all of this. So this is actually going on ahead and making our detection. So to do that, we've written results equals hands.process, and then to that, we've passed through our image, which has had its flag set to false, and it's also being converted to RGB. So this actually makes our detections. Then we've gone and set our writable flag back to true. So this is going to allow us to render to this particular image or draw on this particular image. So we've set that flag back to true. And then what we've gone and done is we've gone and recolored it back to BGR. So again, we've gone and converted it from RGB to BGR. And then what we're doing is we're actually printing out our detection results down here. So this should actually allow us to see our detections. And to do that, we've written print, and then to that, we've passed through results. So also on these flags, so we've set image.flags.writable equals to true, and then to convert back to BGR, we've written image equals cv2.cvt color, pass through this image over here, or pretty much the one that we set up over here. And then instead of having BGR to RGB like we did up here, we've actually gone and set it to RGB to BGR to convert it back to BGR. So as of right now, you won't actually see anything rendered to our image. It's still going to be the same old image until we actually go and apply our drawing utilities. So let's run this for now, and then we'll come back and we'll take a look at what it looks like. So again, if I'll run it, ideally what you should see is that our results printed out now. So printed out as in printing out the string, not actually anything rendered to the image, but that's fine. Okay, so it looks like our frame popped up but then closed. So if you do get that, just run it again and you should be good to go. Okay, so our image, so we've got our real-time feed, still pretty quick. And you can see down here, we're getting all of our solution outputs from MediaPipe. So that's looking good. Now, if we actually quit out of our frame, this is actually a good sign. So if we actually type in results now, you can see that we've got our MediaPipe solution down there. And if we actually type in .hand, I believe it's .hand, it should be multi-hand landmarks. So rather than hand, it's multi-hand landmarks. Oh, doesn't look like we got any. Okay, this is actually interesting. So we don't actually have any landmarks at the moment. And this is because we didn't actually put our hand in the frame. So let's try that again. I'm just going to make sure my hand is in the frame now so we actually get some results. All right, so close again. Let's try running that again. Perfect. All right, cool. So our hand's in the frame, and I'm just going to quit out of this. And now if we actually go on and access results, we should get the results from the last frame detected. In this case, you can see that we've got all of our landmarks. And from here, you can see that we've got our landmark, and each landmark is represented by an X, Y, and a Z coordinate. So X is going to be the X axis, Y is going to be the Y axis, and Z is the estimated distance from the camera, I believe. So that is all well and good. But now what we actually want to do is actually go and render our results. So let's go on ahead and do this so we'll actually see our results shown to the screen. Okay, so that or those 3 lines of code should now allow us to actually draw our landmarks to our image. Now, there's one last change that we actually need to do here. Or let's actually take a look at those 3 lines of code first, and then I'll show you the last change. So this is actually rendering results. So first up, what we're doing is we're checking whether or not we've actually got any results in our results array or our results variable. So this is going if results.multi_hand_landmarks. And this is basically checking if there's anything in there. If not, we're going to skip our rendering. And then what we're doing is we're actually looping through each one of our results inside of the multi-hand landmarks variable. So which is what we saw down here. So to do that, we've written for num, hand in enumerate results.multi_hand_landmarks. And the reason why I've used enumerate is because in the follow-up video, we're actually going to do something a little bit more sophisticated with the results. So again, this is sort of future-proofing for the next tutorial. Then what I've gone and written is mp_drawing.draw_landmarks. And to that, we've passed through 3 variables. So the image, the hand, so in this case, this is going to be this variable. So we're going to loop through each set of results. And then we're also passing through mp_hand.handConnections. So really our image is going to be the image that we've been working with so far. And really that's the image from our webcam. Our hand at that particular point in time is going to be our set of landmarks from our results.multi_hand_landmarks variable. And then our mp.handConnections really represents the sets of coordinates, right? So let me, it should be mp_hands. This should be mp/hands. Okay, so this really represents our hand connections. So basically what this is saying is that the wrist is connected to this joint, the wrist is connected to this joint, and it basically shows you the sets of relationships. So this joint is connected to this joint is connected to this joint, so on and so forth. So it basically allows you to draw the connections. Now there's one last change that we actually need to apply. And right now we're still rendering our frame. So this is our raw webcam feed that we got from up here. But what we actually want to do is pass through our image, which has now had our different joints actually rendered to it. So all we need to do that, let's get rid of some of these spaces, is type in image here. So replace our frame with image. And now what we should get is our results rendered to the screen. So let's go on ahead and run this. Okay, we have the pop-up and a close, run it again. And close again. Got to debug why that's happening. So again, if you get the little gray pop up and then it closes, ideally just rerun it again. Okay, so we've got our webcam feed. That's all looking good. If I stand up now, you can see that we've got our hand tracking working. And again, it's quite accurate and fast as well. So you can see I'm moving my hand around, still tracking relatively quickly. And again, we can do 2 hands as well. So again, you can do this really, or you can apply it to a whole bunch of different use cases. Now, the cool thing about this is that you can actually do it for more than just 2 hands. So say, for example, you had multiple people in the frame, you can actually pass through a variable to this line here, which I believe is max num hands. And if I go and take a look, I believe that's a parameter, max num. Yeah, so if you pass through max num hands, you can actually bump this up. So at the moment, it's detecting a maximum number of 2 hands. That's the default. But if you wanted to apply this or pass through more than 2 hands to your frame at a particular point in time, you could definitely bump that up to be able to render more results to the screen. But for now, that's pretty good, right? So we're rendering our hands. But again, as per usual, my OCD is kicking in and I don't like displaying things in red and green. So let's go on ahead and change the coloring of this. So for this, we're going to use something called a drawing spec. So let's hit Q on this frame and close this out and go and apply our drawing spec. So we're going to make an update to this mp_drawing line to be able to go on ahead and change our colors. Now, specifically, let's actually take a look at this mp_drawing function. So mp_drawing.draw landmarks. So to this function, you can actually pass through 5 different variables. So in this case, you can pass through your image, your landmark list, which in this particular point in time is our hand detection or our hand landmarks. Then you can pass through your connection list, which is our hand connections over here. But then you can also pass through a landmark drawing spec and a connection drawing spec. So your landmark drawing spec represents the colors for your joints or your landmarks, and then the connection represents the color for your lines. Think of it as your bones. So we're going to go on ahead and pass through 2 drawing specs to be able to change our colors. So let's go on ahead and do this. Okay, so those are our drawing specs now applied. So I've gone and done or written 2 additional lines of code there. And these lines of code are just passed through to our draw landmarks function that we already had up here. So specifically, I've passed through mp underscore drawing dot drawing spec, and then I've passed through 3 keyword variables. So I've passed through a color variable, a thickness variable, and a circle radius variable. If I actually show you the mp underscore drawing dot drawing spec, let's pass through question mark, question mark. So you can see here that you can pass through 3 variables to this. So color, in this case, we'll pass through our color. And in this case, it's going to be in the format of BGR because we've already converted our image back to BGR before we go and render. So we've passed through our drawing spec. We have passed through our thickness. So the thickness is going to represent your line thickness. And then we've also passed through our circle radius. So in this case, if we're drawing a landmark, it's going to change the size of your circle. If you're drawing a line, the thickness parameter is going to change the thickness of your line on your finger. So we've gone and passed through 2 of those. So to do that, we've written mp underscore drawing dot drawing spec, and then we've said color equals, and then inside of brackets, 121, 22, 76. So if you wanted to change the color, all you need to do is just pass through a different color combination. So remember, it's blue, the blue value, the blue value, the green value, and then the red value. And then we've also passed through our line thickness. We've set that equal to 2. And then our circle radius. So circle underscore radius equals 4. Then we've gone and passed through another drawing spec. So this one is actually for I believe this is the line. So to do that, again, we've written the exact same line. The only difference is that I've gone and passed through a different color so we can differentiate the joints or our landmarks from our connections. So this color is going to be blue. So 121, green, 44, and then red 250. Now set thickness to 2 and circle radius equal to 2 as well. Cool, that's all well and good. I think we're good to render this now. So let's go on ahead and run this. Maybe we'll get a pop-up. Nope, closed. Try that again. All right, cool. So we've got our webcam feed. It's all working. You can see that we've now gone and changed the color of our hands. Pretty cool, right? And this will work with or without a green screen. So I've obviously got a green screen up, but you can see it's still tracking relatively well, even with a complex background. So all well and good, working pretty cool there. Now, if we wanted to, we could actually change our color, right? So say, for example, I change this from 44 to, I don't know, let's actually change this value. So blue, green, red. So if I set this to 250 and then run it again, this should change the color of our lines now. Let's wait and see. Let's run it again. Cool. And so you can see that our line is now more purple than pink, right? But again, so you can sort of see that you've got full flexibility to work with this stuff as well, right? Pretty cool, right? Alrighty. In that particular case, so that is really step 2 done now. So we've gone and done a bunch of stuff. So we've gone and rendered our image. We've gone and drawn our results to the array. Now, there's one last thing that you can actually do. So what I want to do in this particular tutorial is actually flip the image on the horizontal, because when we go and do some of the more sophisticated stuff in the next video, we actually want our frame to be flipped. So we ideally want to be able to detect our left hand and our right hand. So what we can do is just pass through a flipping function. So image cv2.flip, pass through our image, and then we want to pass through 1. So this is going to allow us to flip our image on the horizontal. So flip on horizontal. Alrighty, let's try that now. So ideally you should see that the frame is actually flipped on the horizontal now. You won't see anything with the green screen in the background, but I'll take it down again. Cool. So you can see that my microphone is now on this side. Again, all still rendering pretty okay. Take the green screen down. Again, you can see that the image is now flipped. Pretty cool, right? Now, the last thing that I want to do is show you how to actually save these captures. So say, for example, you wanted to show your friends or you wanted to actually produce results for a paper, you can actually save the results from each one of these detections. So let's quit out of this and go and wrap this up. So the first thing that we're going to do in order to output our images is actually make a new folder within our current directory. So to do that, we can write os.makedir. Let me just double check, and we're going to call it output images. So this should create a new directory in the current place that you're working. So let's go and take a look. And you can see that now I've gone and got a folder called output images. So I'm just going to delete that. Let me do it again so you can sort of see it. So as of right now, we don't have a folder called output images. So if I run that, and now we go and take a look, it's gone and created it again. So this gives us a folder to now work with. Now what I'm going to do is I'm actually going to copy all of this code and paste it down here. And there's really just one change that we need to go and apply it to our baseline code to be able to go and save our images. So let's go on ahead and do this, and then we'll wrap it all up. Alrighty, that is our last line of code now done. So this line of code here is actually going to save our image. So if I go and take a look at what we've written there, there's quite a few functions stacked together. So let's actually break this down. So if I bring that there and I bring this down, and I think that's looking good. Okay, so what we've actually got first up is we're naming our image, right? So this line of code is actually naming our image. Now let me actually show you what that does. So to name our image, we're basically using our UUID library that we brought in right up here. And again, UUID creates a unique identifier. So if I type in UUID.UUID1, you can see it's going to generate this string here. And really, this is going to be the name of our file. Now, what we're doing is we're actually using some string formatting to be able to go and name our file. So if I show you what that line does, so if I go and actually copy this, should be that. So you can see that it's going to go and append our unique identifier .jpg to be able to go and name our file. And the reason that we do this is so that we don't have any conflicts when we go and output our image. We want it to be a unique identifier. Then what we're doing is we're going and creating a path to be able to determine where our file is going to be output. So to do that, we've written os.path.join, and then we're going to store it in our output images folder. And then we need to pass through our file name. So that gives us this. And so this basically specifies that we're going to be outputting our image to the folder output images. And then because I'm on a Windows machine, the file path is a double backslash, but on a Mac or Linux, it'll be a /. And then we're passing through the name of our image here, which has been randomly generated on the fly. And then the last thing that we're doing is we're actually using the cv2.imWrite method to be able to go and write out our image. So we effectively pass through cv2 or write cv2.imWrite, which gives us, so the first parameter that we pass through is the file path to our image. And then the second parameter is our actual image itself. So if we actually ran this now, let's go and take a look. So ideally we should have a feed from our last detection. So it'll be in hand pose, output images. And all right, so you can see that it's gone and grabbed our last frame from our last detection. In this case, it doesn't actually have any hands on the screen. But that's well and good. So we know that that's actually working now. So this line of code is exactly the same as this. So if we bring it into one line, that is all well and good. Cool. Now, if we run this, so it's actually going to save every single image that we actually process from our webcam. So if I actually delete this line here and run this new code, so for every single detection that we actually make, we're actually going to see the results output to this folder over here. So let's bring this to the side and this over here. And if we actually run this now, you should see all of our images start populating over here. So let's go ahead and run it. Ideally, we should get a pop-up. We'll see if it works the first time. All right, that's all working well. Cool. So you can see all of our detections and you can see that we're actually drawing them. They're being saved to our folder. Pretty cool, right? And it's pretty quick. So if you wanted to go and share this, put it in a paper, save it for a research project, you could definitely do that, right? And again, I could keep messing around, hit Q, and you can see we've got all of our different images now saved. So again, you can work with these, you can go and output them, and they're going to be in the same resolution as our actual frame. So if you actually flick through them, you can see me moving. It's almost like a stop motion. Pretty cool, right? But on that note, that actually wraps up this tutorial. So we've gone and done a bunch of stuff here. So first up, what we did is we installed and imported our dependencies. We went and took a look at the landmark map for the hand model. We then went and actually made some detections from our webcam, rendered it, applied some custom coloring, which you saw down here. And then the last thing that we actually did is we actually saved our output. So if we wanted to go take this, embed it in something else, you could definitely do that. But on that note, that about wraps it up. Thanks so much for tuning in, guys. Hopefully you enjoyed this video. If you did, be sure to give it a thumbs up, hit subscribe, and tick that bell so you get notified of when I release future videos. And let me know what other videos you'd like to see and what you ended up using the MediaPipe hand pose model for. Thanks again for tuning in. Peace.